Disagree if you can. R-squared is the most important interview question in data science or machine learning interviews. Is there anyone who says that there is no question about R-squared in the interview? Definitely no. R-squared is the most important metric to evaluate the regression-based models. So let me show you how to compute R-squared mathematically as well as with the help of Python. If you really want to get placed in any of the data science based jobs, watch the video without skipping any part of the video. And if possible, hit like, and you can also give your awesome comments to me. At the same time, try to circulate it in your groups, right? So first, let's try to understand what is R-squared. Have you ever written this anywhere? Yes. We write model is equal to linear regression and then model dot score X train, Y train, model dot score, X test and Y test, right? So what does this dot score represent? This is nothing but R-squared, right? So let us now go slowly to understand the concept of R-squared. Now you may be asking like, Lata, can you please show me the definition, right? Nobody wants your definition. They really want how much you have understood the concept, right? So if you want, you can take a screenshot of it, right? So to understand this better, I have taken a data set where what I have done is I have taken area as well as price, where area is the independent variable and price is the dependent variable. What do I mean by independent and dependent variable? Based upon the area, I'm trying to predict the price of a house or land, whatever it is, right? So for this, what I'm doing, I'm importing NumPy pandas and linear regression model as well as R-squared. So I assume that everybody already know it, right? In case if you really do not know, you need to look into my previous videos of linear regression. And then if you come back, I think you would be able to understand it very well, right? If you already know it, very good, you can definitely understand this. If you really do not know linear regression, please go back to my previous video. If possible, I will give it in the description window. You can just click on that, watch the video and come back, okay? So for this, I have created this data set. Area is this and price is this. That is what I have displayed it over here, right? So now if you see this, as I told you, price is the dependent variable. So I have taken it in y-axis and area is the independent variable. So what the linear regression generally does, it tries to build the relationship between independent variable and dependent variable. Basically, I want to find out price is equal to how many times area, right? So this is what actually I want to find out. So I have instantiated my model and fitted with x comma y, train and test. For now, I'm skipping it off. So I'm trying to get the intercept as well as the slope. So you can see intercept is 109 and slope is 0.16. So let me show you what does this actually indicate, right? So what does this indicate? We know that y is equal to mx plus c. What is y according to this data set, which is basically price? So price is equal to m is nothing but slope. What is the slope value? You can see 0.1644, right? Times x. What is x? X is nothing but area. Plus c. C is intercept, 109.86. Actually, this is the relationship that has been built by the model. So I really want to know whether this is correct or not. Can I go ahead with this or not? So what I'm doing, let me predict the value of y so that I'll come to know whether how far the distance between the actual and predicted value is. So I'm just going ahead with the prediction. So now you can see that, okay, let me clear it off. Now you can see that it is predicting 241, but the actual value, if you see, that's basically 250. It should be 300, but it is predicting like 307. 350 is predicted like 356, 400 as 405, 450 as 438. So we could definitely see that there is difference between actual value of y which is given in the data set, and the predicted value of y, which has been predicted by our model, right? So this formula, you might have seen it, right? R square equal to 1 minus y hat the whole square divided by y minus y bar the whole square. It's very simple, right? Y is nothing but the actual value of y, which is given in the data set. This has been the predicted value of y, right? This is actual y. And again, this is actual value of y, same thing. Y bar is nothing but mean y, right? So in general, what is this? Like how this is being calculated? Summation yi minus yi hat the whole square. Here there would be 1 by n, and 1 by n summation yi minus y bar the whole square. Have you ever seen this formula anywhere? I know very well that you might have seen this, right? So what is this basically? Exactly. This is nothing but mean square error. What is this? Have you ever seen it? I'm waiting for your response. Exactly. This is variance. So what does this R square tells about? You can see 1 minus mean square error divided by variance, right? So this R square metric is only helpful to evaluate regression based models only, right? In case if you have any other queries, any other questions, if you want me to make more videos, definitely you can ping me. So let's now continue with this, right? So this is the actual value of y, and this is the predicted value of y. So let us now try to compute the numerator, right? Y minus y hat the whole square. So what is the actual value of y? 250 minus this one, right? 241.4473, right? The whole square plus 300 minus 307.24, the whole square plus 350 minus 356.579, the whole square plus 400 minus 405.92, the whole square plus 450 minus 438.8 to the whole square. Right? Everyone, please try to calculate this value and let me know what do you get now. Yes, you can also do it in Google Colab. You can do the calculation in Google Colab also. Excellent. You're super fast, right? So when you calculate this, you would be getting 331.40. Right? So whoever has got this answer, please let me know. 1, 2, 3, 4, 6, 7. So seven participants out of 12 have answered this correctly, right? So when you calculate this, you would be getting this one, right? So this is for the numerator part. So let us come to the denominator part, y bar, right? Y bar. So y bar in the sense, what did I say? Mean value of y. So what are the values we actually had it? 250, 300, 350, 400, 450. Can you tell me the mean of it? Excellent, right? So definitely the mean value is 350, right? So what is the next step we are supposed to do? We need to calculate it for the denominator part. So 350 is the mean, correct? So what we are supposed to do? 250, which is nothing but actual value of y, minus y bar, which is nothing but the mean value. The whole square plus 300 minus 350 the whole square plus 350 minus 350 the whole square plus 400 minus 350 the whole square. I'm so sorry. 450 minus 350 the whole square. I'm again waiting for you. So let me see who is finding out. One, two, Okay, I got multiple responses now. The answer is 25,000. Right? So let us now try to calculate this one. What is this R square, right? So R square. So now if you see 1 minus y minus y hat the whole square, already we have calculated that, and that is 331.40 divided by y minus y bar the whole square, we got it like 25,000, right? So now please calculate this one. Exactly. So you would be getting it like a 0.9868. Let me know whether everybody get the same answer. So let me also see what is the score I'm getting over here. Model.score x comma y. I'm scared. I do not know whether I'm going to get the right result or not. Let me see. Let me see. Yeah, you can see that. Yes, we are getting the same score. So is it a good model? Yes, most probably, because we want R square value close to 1, right? So definitely we can say that, yes, it looks like good model, but again, based upon the domain, we have to check how the actual value and the predicted values are close. For example, if you look into this one, 250 is calculated like 241. 300 is predicted like 307. So maybe you will know whether it is okay or not, right? Otherwise, we need to switch to the other machine learning models. So in case if you consider domains like healthcare or finance, there we cannot take risk like this, right? We really want the actual value close to the predicted value, right? We want the predicted value close to the actual value, right? So remember, R square, always we want it close to 1, right? Then we can say that the model is a good model. So if you want me to make any other videos, please do not hesitate, write it in the comments so that I can make it. I hope all of you are clear with this. Thank you so much.